Good morning, student. Today we will study about the introduction of Mosfet. It is the also member of FET. Mosfet means metal oxide field effect transistor. M for metal, O for oxide, S for semiconductor, F for field, E for effect, or T for transistor. So this is a member of JFET. Sorry, FET or metal oxide semiconductor field effect transistor. So FET is, if the FET is made by growing a very thin layer of SiO2, very thin, 0.1 micrometer. It is very thin, very thin, 0.1 micrometer over a semiconductor material. So this is the difference between FET and MOSFET. When in MOSFET, a very thin layer of SiO2, silicon dioxide layer, is uh, grown by on the semiconductor material. Metals such as aluminum is deposited over the dielectric layer Si2 is known as the MOSFET. So there are two types of MOSFET, enhancement type MOSFET or depletion type MOSFET. Each MOSFET, enhancement type MOSFET or depletion type MOSFET can further divide into two parts, P-channel enhancement MOSFET and channel enhancement MOSFET, where the depletion type MOSFET can further divide into two parts, N channel depletion MOSFET and P-channel depletion MOSFET. So these are the groups of MOSFET, and here we will see about the enhancement mode, enhancement MOSFET mode. So when there is no uh, gate voltage on the gate, when there is no voltage on the gate, the device does not conduct. That because the enhancement mode, the channel does not exist between the drain and source. You can see here, you can see the here that there is a break between the drain and source. So you can see there is a line break between the drain and source. The lines and breaks, this shows that channel does not exist between the drain and source. So to flow of the charge carriers from source to drain, the channel should be present. So, but the channel is not there, hence the current does not flow. When the gate, there is no voltage on the gate. So by applying the voltage on the gate, we form the channel between the drain and source. And as soon as the channel is formed between the drain and source, uh, device can conduct. The current will conduct in the device. So here, the more voltage on the gate, the better the device can conduct, because the channel will be formed by applying the voltage at the gate, right? So this is the symbol of N channel enhancement MOSFET, and this is the symbol of P channel enhancement MOSFET, right? uh, Next, depletion mode. In depletion mode, there's a we can see here that uh, line is not break, means channel exists between the drain and source. The channel exists between the drain and source, and channel exists, so the even the gate voltage zero, the current will flow between the drain and source. So by applying the gate voltage, we can control the current. ठीक है. So the at the gate terminal we can apply the positive volt or the uh, negative field or the positive field. So by applying the positive field or negative field, the gate current will be, sorry, the current between the source and drain can be controlled, right? So when no voltage on the gate, the channel shows its maximum conductance. जब गेट पे कोई वोल्टेज नहीं होता तो ये चैनल का मैक्सिमम करंट फ्लो होता है. As the voltage on the gate is either positive or negative, the channel conductivity decreases. So this is the difference between the depletion mode and enhancement mode, because in depletion mode, the channel does not exist between the drain and source, but in the depletion mode, the channel exists between the drain and source. So this is the structure, this is the construction of a enhancement MOSFET, P-channel enhancement MOSFET. So by construction, to construct the P-channel enhancement MOSFET, we take N-type substrate. This is the N-type substrate, which is shown in the sky blue color here. So this is the N-channel MOSFET, and by N-channel MOSFET, we take n-type substrate. We take n-type substrate, and in n-type substrate, two heavily doped p-type regions are there in the body, separated by a certain length, and we diffuse two p-type body, p-type regions which are apart by a certain distance L. So this is in this way, and after diffuse the p-type regions at a certain distance L, we grown the SiO2 layer. We grown the SiO2 layer between uh, these two p regions and over the surface of n-type regions. So there is a thin layer of silicon dioxide on the top of the substrate, and we may also use this for the purpose of, but SiO2 is more common. SiO2 is used. SiO2 के space instead of SiO2 we can also use Al2O3. But most commonly SiO2 is a good dielectric constant. So this layer on the substrate behaves as a dielectric. There is an aluminum plate fitted on the top of the SiO2 dielectric. Now the aluminum plate dielectric and the semiconductor substrates form a capacitor on the device. The terminals connected to two regions are source and the drain, just like an FET. On the device respectively, the terminal projected from the aluminum plate or the SiO2 layer is the gate of the device. So we also connect the source and the body of substrate. We also connect the source and the substrate body internally connected to provide the earth facility of the MOSFET. This is N channel. So, but here you can see that the channel does not exist between the drain and source. But after applying the gate, after applying the field at the gate terminal, the channel will be exist between the drain and source. The negative voltage in the drain reduces the voltage difference between the gate and drain reduces. As a result, the width of the conductive channel gets reduced towards the drain region, as shown below. At the same time, the current flows from source to drain by the arrowhead. So by the arrowhead. So, but in enhancement MOSFET, the current will flow after the creation, after the formation of N channel between the source and drain, and N channel will be formed by applying the field at the gate terminal. And this is the VI characteristics of a VDS and ID, drain current or drain source voltage as the input at constant VGS. So this characteristic again same as the characteristics of FET, which we have studied. And this is the ohmic region in which we increase the voltage, the current will increases. This is the saturation region or pinch off region. This is also known as saturation region or pinch off region, in which the current becomes constant. So, and this is transfer characteristics. This is transfer characteristics, and this is the drain characteristics or output characteristics. B region is known as the drain characteristics or output characteristics, and this is the transfer characteristics, which shows the relation between the gate source voltage and drain current. So from here we can say the gate source voltage is increases, the current will not increases, because the channel width is not, channel will not be formed, and channel will be formed when the gate source voltage becomes the reaches at the pinch off voltage, threshold voltage. Threshold voltage. Here Vt is the threshold voltage. So when the gate source voltage reaches at the threshold voltage, the sufficient channel will be formed between the drain and source. And now if the sufficient channel is formed, if we increase the voltage, current will increases in enhancement type MOSFET. So this is the transfer transfer characteristics, and this is the drain characteristics or output characteristics. Okay, thank you.